Difference we are going to see here, graph representations. There are two representations used in order to represent a graph in the computer. One is called a static representation, the other is a dynamic representation. So in the static we have adjacency matrix representation, the other one is adjacency list. So in matrix, as we said, we use a table, a matrix, row into column for representing. Let's imagine this same graph that we have seen before in the previous video. We're having 5 nodes and these are the edges. So here is a standard definition how it is represented. Now nothing, if the graph has got n nodes, then we use an n into n square matrix. And for any time for a node aij, if there is an edge from I to j, then we make the entry in the matrix 1, otherwise 0. Sometimes a weight itself can be entered. So we'll just consider this too. So from A to A, there is no edge, which means there is no looping here. Sometimes you can have, since there is no edge, it is 0. Then A to B, there is an edge. A to B, there is an edge, so there is 1. Similarly, A to C, there is an edge, A to C, so it is 1. But there is no edge from A to D, no direct edge, so it is 0. Similarly, no A to E, so it is 0. Similarly, if you look here, we have the edges marked, and I would leave you to fill up these. So this is adjacency matrix representation and often used to represent a graph. So sometimes a practical or theoretical question could be this: represent a graph, a given graph using adjacency matrix. So build your own graph and make the entries correctly and make the n into n square matrix and make the entries. Sometimes you can also represent for a given graph as a program symbol, create a two-dimensional array and make the entries for if there is an edge from A to I or I to J, then that is made 1. So if there is an edge from I to J, for example, in this case it will be 1. If there is no edge from I to J, that would be 0. So similarly, edges can be entered, also can be deleted. Suppose I want to delete this edge, which means A to C would become no edge, which means A to C would become 0. Sorry, A to C would become 0. So that can also be done. So that is the first representation that we use, that is to represent a graph using adjacency matrix.